Hey, good morning. It's Jay. My week is beginning, and so is yours likely. And it's time to learn something new. It's early here. It's 10:15 in the morning. I figured I would do a stream and just go through the deploy and manage resources in Azure by using Bicep learning path on Microsoft Learn. It's really easy to get started with. It'll help you go through some concepts of infrastructure as code, talk a little bit about ARM templates, show you like kind of the difference about deploying via, say, a bash script using just some Azure CLI commands. I think that you'll get some real interesting tidbits out of this session. It won't be very long, so just give me a few minutes of your day and let's do this together, okay? Hey, it's going pretty well. So if you'd like to leave some notes in the chat, you can feel free. I'll be able to see them and give you some answers if I can. Other than that, why don't we get started? Okay. So let me give you the URL if you'd like to follow along. It's right there. Deploy and manage resources in Azure by using Bicep. You can go to that URL that I've got there in the overlay there, but I'll also put it in the comments. So here you go. So if you go to this URL right there, you can follow me along in what we're going to be doing. I'll talk you through it a little bit. And then eventually what we'll do is deploy our resources that our Learn module goes through. Okay, so I'm going to bring up our screen and we'll get started. If you head over to the URL, you're going to get the deploy and manage resources in Azure by using Bicep. So it says it takes about 3 hours and 57 minutes to do. But to be honest with you, it's not going to take you that long. If you want to just kind of run through the resources. If you want to learn every single part about this, I recommend taking your time, reading all of it. And so let's get started. Bicep enables you to deploy Azure resources. Bicep uses a declarative syntax that you treat like application code. So treating your infrastructure as code enables you to track changes to your infrastructure requirements and makes your deployments more consistent and repeatable. So what I like to think about in that statement is that rather than have a series of commands that you run to deploy your application infrastructure, you're using code, and that code may be in a specific DSL. That code, it essentially will allow you to preserve it and handle all the little bits and pieces of tracking changes. So you can keep your code in a repository, go back to it, make changes, deploy it again. So if you're familiar with JSON, that's what ARM templates are in. ARM templates use just standard JSON, and it gives a standard syntax that if you run through almost anything that you build in Azure, you'll get some JSON response of what exactly was built. But to actually give something, you can use this template file that are called Azure Resource Manager templates. Azure Resource Manager is a control plane for Azure. It's unified across the entire platform, and you can use it to create just about any resource that exists in Azure. So I've got my dashboard here. I'm going to open up another dashboard. And what I've done is just brought up the Cloud Shell, shell.azure.com. And what we'll be able to do is to kind of have an eye on the resources that we create. So why don't we go through that? We'll get started by looking a little bit at the prerequisites. You should have a little bit of a familiarity with Resource Manager. Resource groups is recommended but not required. And so let's see. We're going to start here with Introduction to Infrastructure as Code using Bicep. Let's go ahead and click that. That's going to bring us to the first module. It's 40 minutes long. We should not have to use 40 minutes because I'm going to kind of summarize some of the things. But the learning objectives are pretty clear. We're going to describe the benefits of infrastructure as code, describe what the differences between declarative and imperative infrastructure as code and explain what Bicep is and how it fits into that infrastructure as code approach. Okay. It says that you should be familiar with basic cloud computing and you should be familiar with different types of cloud resources. So I'm guessing if you're using Azure already, you're probably pretty familiar with what cloud computing is and how some of the major terminology like virtual machines and the different services that you want to utilize, elasticity. You should understand all these things if you want to feel successful doing this learning path. You should be familiar with the different types of cloud resources. So specifically on Azure, like I said, virtual machines, app services, storage, security services, all those, you should have a little bit of understanding. And so this module, it's part of that to whole deploy and manage resources in Azure by using Bicep. So let's go to the introduction. As you can see, I've gone through this already. So I get my green checks for everything, and that leads to experience points. So create this into a competition with your coworkers or your friends or whatever. Work together, see who gets the most points. I think it's cool. Let's go to introduction. Infrastructure as code is the process of provisioning infrastructure resources similar to how software is deployed. So it's basically telling you that you can utilize code to effectively create your different virtualized resources on a cloud or any other place, because you can use infrastructure as code on-prem. So if you have, say, bare metal servers and you want to deploy things consistently, you can utilize something. In my time, I've used Terraform, Ansible, Chef, Puppet, even spent a few minutes with Pulumi, and all those really kind of aim to do one thing, is to have a genericized version of infrastructure as code deployment with modules for those individual cloud providers or on-prem. In this case, Bicep is specific to Azure and Azure resources. So if you're an Azure infrastructure administrator at a toy company experiencing some growth in the market, you'll need to scale your infrastructure quickly. So deployments of new applications need to be created. For those teams and customers, we need to have multi-regional deployments to support customers and partners, and we need a multi-cloud environment for deployments. So that's where being able to use a number of different types of technologies to make everything come together is important. Like I said, Bicep is going to be specific to Azure, but if you use one of those more genericized infrastructure as code platforms, you'll be able to hopefully just write one big kind of set and then have a deployment module that you're accessing per environment. So if you're deploying to, say, another big major cloud and Azure and doing something like a failover, you can utilize one particular type of infrastructure as code model, like, say, Pulumi or Ansible. But in this case, we're just going to go through our Bicep deployment. And so in this module, you'll learn about the concept of infrastructure as code. So what is it? How can it help you with automated resource provisioning? What is Bicep? And then when should you use this instead of other tooling options? So what is the main goal? After completing this module, you should be able to determine whether infrastructure as code is the right approach and tool for your organization. And so I honestly believe that it should be. Infrastructure as code makes sense to me because we're storing everything, we're keeping it. So let's go to the next unit. What is infrastructure as code? So you've been asked to evaluate whether infrastructure as code might be valuable. And so you're reviewing the available options. And so all of these are capable. You can use an Azure Portal. So that means going through here, create a resource, picking which type of resource you want, next, last. And so that's going to take a little bit of a time to do because you're going to have to go through each individual resource parameter and configure it yourself. Now, let's say what we want to do is use the Azure CLI. So we could create our resources using something like AZ, like group create, then create the group. Then we can use AC VM and then give one of the sub commands. So we can do this, and it's all kind of the same. And the same goes for PowerShell. If you're using PowerShell locally, and you have the Azure module configured, or you can use the PowerShell deployment in the Cloud Shell that's already set up for you in your Azure account. You can do almost any single thing that you could do with the Azure CLI. And then there's ARM templates, and specifically there's the standard JSON, and then there's the Bicep method. So let's quickly take a look at this Azure, Playground. Bicep Playground. So let's go to the Bicep Playground. I love this website, and I think one of the big reasons why it works for me so well. Let's see, might be just a little slow. So what's great about this particular, and I'll put it in the chat, is you're able to take a look at a number of different templates from this side being the Azure Resource Manager template, and then this version is in Bicep. So in the Bicep version, we have 195 lines. In the actual ARM template version, we got 242 lines. So that's giving you a major idea of the difference in how much you're actually writing to utilize Bicep. But you can see right here, let me bring this out for you a little bit. Here's what an Azure Resource Manager template looks like. It's JSON. It comes with a specific schema that you can look at based on the URL at the top. We see the version of our template. We can add metadata. Then we can go ahead and actually set some function or some variables for the different resources we want to create. In this case, I believe what we're doing in here is creating a virtual machine with a network security group, and then using primary and secondary network cards, and then assigning a public IP to one of those network cards and a network security group to that. So that's how that looks like in general. And so if you're looking for a repeatable option, these templates tend to be a little bit more, whether you're using ARM or using Bicep, they're repeatable. You can add them as part of your deployment pipeline. You can have something like GitHub Actions kick off a new job when you make some changes, create a brand new version of your environment. That includes all the resources that you'll need. So defining infrastructure as code. Your company designs new toys. The company's design team creates instruction manuals. Each manual provides details on how to properly assemble the toy. And so, like, I really love this analogy. You can think of infrastructure as code as being like the instruction manual for your infrastructure. And so rather than doing all the parts manually and spending time putting everything together, we can use a template. And so what I just talked about, like your CI/CD pipeline, here's an example in this image. I think it's really good. Let me make that bigger for you. So this image is great because it essentially says that what we're doing is we're kicking off a process via one of our CI/CD providers, be it GitHub or Azure DevOps. They're reading the template, and that template is essentially telling them, I want you to create these services. So rather than someone going through the process manually after you say commit a new branch, have a PR merged into your main application code, you can have it so that GitHub Actions will see that change and then kick off a template run. And so you'll have your infrastructure created for you. So one option is to detail each step of the build process. Another is to show an exploded view of the pieces and the parts needed to assemble the toy. Later in the unit, we're going to learn about differences between imperative and declarative and how they relate to your company's instruction manuals. So why use infrastructure as code? Increase confidence in your deployments. So you already know what's being done because you've codified it. And so you have a little bit more confidence in what you're building. Manage multiple environments. So if you want to have a development environment, a test environment, and then a prod environment. You could essentially build each individual environment. You can create them in separate resource groups with some metadata that says the difference between the two, so that you can actually do deployments based on which environment you want to use. And that in process will help you, I don't know, just reduce the amount of manual overhead you'd have to do with 3 different environments. You can just essentially keep one code base of your resources and say your Git repo, and then make some flags for each individual environment that you might be deploying to. So we can increase confidence, integration with your current processes, consistency, automated scanning. So we can use tooling to look for problems with linting, things like that. Manage multiple environments. And that, like I said, we can provision new environments on the fly. We can create non-production environments. We can have a DR environment. Hey, Kevin, thanks for joining me. And then let's see. I need to push my data factory from dev to prod using an ARM template. Looking forward to using Bicep. I'm looking forward to you using it too. I really am. I like that you are all taking part. And if you got anything more to say, feel free. So DR, another real good reason to have a version of your environment created, being able to spin up stuff quickly, and then to better understand your cloud resources, an audit trail. So changes to your infrastructure as code or version control. We keep everything in a Git repository. We can go back to that Git repository if we need to. Documentation. So leave comments within the actual ARM template, or I should say Bicep template or ARM template, whatever your infrastructure as code methodology is. Unified system. Many times when a developer is working on a new feature, they must make changes to the application code and infra code by utilizing a common system. So one, say, Git source of truth, you can keep everything then there and understand that relationship. And then a better understanding of your cloud infrastructure, because it's all written out for you. And I think that that's really useful. So let's head over to imperative and declarative code. Let's talk about what the difference is. With imperative code, you execute a sequence of commands in a specific order to reach an end configuration. And this process defines what code should accomplish, and it defines how to accomplish the task. An imperative approach is like a step-by-step instruction manual. So we give an example here of an imperative code, which is basically like a bash command. So I can just copy it here. So I need to create a resource group. And so that's the first thing it does. And we could literally just copy and paste. And that's essentially what's going to be done. Imperatively, it's going to say, all right, this is step 1. Let's do step 1. And then here, if we do this and we create, we're not going to do it right now, this would have been basically be step 2 in that bash script. So imperative means we're just going to be running it one at a time. And so like it says here, the first command creates a resource group. And then the second creates an account for storage called my storage account in the storage resource group. So it's the best way to put it is doing something like this imperatively using a bash shell. It's fast, easy, it's quick, it's dirty. It's not going to always have the most up-to-date commands that are available, which is something that we need to concern ourselves with. Because if like something changes, one of these AZCLI methods are somehow or another different, that can automatically just break your code, and you're going to need to do something a little bit different. So declarative code is an approach accomplished by using templates, and many types of templates are available. Like we talked about before, JSON, just the standard JSON template, a Bicep template. And Bicep is its own DSL, domain-specific language. Ansible, right? Red Hat, that's using, I believe, just JSON. Is there a module for best practices for creating IAC? How should the resource be broken out? You know, that's a good question. I think when you're creating something, I think it's best to kind of utilize and link templates together. so that you can have a process that will go ahead and create multiple resources and kind of use one another's dependencies. So I definitely recommend looking at how things are linked in Bicep and how you can link together those templates a little bit further down the line. The module that we're working on, it's going to focus on a Bicep template. And so this is an example template right here. So this resource, what I love that you can do, if you're creating this on your own, I'll bring up VS Code for a second. If you bring this up on your own in a VS Code file, let's do a new file and let's give it a name, because I have the Bicep VS Code plugin configured. So let's go here. I have to save the file. Okay, let me go to, okay. So let's just do a little something here. Save it, and what we're going to be calling it, there we go, desktop. We're just going to call this demo.bicep. And so demo.bicep, you'll see that Bicep is recognized now as the template file. And so that means that you can get use of some of the IntelliSense auto completion. So it's launching the Bicep service. Let's give that a second. I'm going a little off the beaten path here, but you can see right here that once I start REST, it'll show me all these different resources that I could create using it. So if I wanted to create, say, a network security group, there we go. All of this is filled out for you, snippets, and now all you have to do is personalize it for wherever your deployment is. So that's how you could use the VS Code to start working with a template. As you can see here, we have our name of our resource that we're going to be creating, my storage account. The location is going to be East US. The SKU, this type of storage is going to be standard LRS. The kind is V2. Properties, now we can add specific properties that if we want our access to your hot, if we want it to be HTTPS only, true. So the resources section defines the storage account configuration. This contains the name, location, properties, including its SKU. You might notice that Bicep template doesn't specify how to deploy the storage account. It specifies only what the storage account needs to look like. Okay. So the actual steps that are executed behind the scenes to create the storage account or to update it to match specification are left for Azure to decide. So we just give instruction, and Azure then goes and says, well, I need this storage V2. It has to be hot. It has to be named this. I'm going to go ahead and do that because that's what was asked of me. So what is ARM? Let's continue. You've spent some time learning the benefits of infrastructure as code. What exactly is ARM? Azure Resource Manager is the service that's used to deploy and manage resources in Azure. So what we can do is utilize this for as our control plane. So if you think about Kubernetes as a control plane for containers, Azure Resource Manager is a control plane for Azure. So you can use it to update, create, delete your resources, modify them, whatever it is you need to do. There are all these different tools. Like I said, the portal, Bash, using Azure CLI. There's also different types of SDKs. So you could actually use a particular language that you may be more familiar with to do this. So if you wanted to build your resources and use Java, you could do that. So the terminology, there are resources and resource groups. Resource is a manageable item that's available on the Azure platform. So like a virtual network, VM, storage account, web app, databases, type of resources. A resource group is a logical container that holds your related resources for an Azure solution. And my favorite analogy about a resource group is it's like an egg carton. What you can do is you can take your egg carton You can have multiple egg cartons. You can put eggs in one of them. You can take them out. If you want to, you can move one egg from one carton to another. And let's say the entire batch of eggs is bad, or maybe you accidentally crack them. You could take that egg carton, throw it away, and be done with it. And so that you can just then get another egg carton and start putting in your resources. They're just places to put your resources. There is the subscription. That's where your billing is being drawn down from. There's your management group, a logical container that you use to manage more than one subscription. You can define a hierarchy of management groups, subscriptions, resource groups, and resources to effectively manage access policies and compliance through inheritance. And then a template, an ARM template, is a file that defines your resources to a resource group, a subscription, a management. So you can specify what your subscription is, which management group, all that within these templates. And there are two types of ARM templates now. There's JSON and there's Bicep. It used to be just JSON. Now we've allowed Bicep to be another methodology. So the benefits: you can deploy, manage, and monitor the resources in a solution as a group instead of individually. You can redeploy your solution throughout the development lifecycle and have the confidence that your resources deployed in a consistent state. And you can manage your infrastructure through declarative templates instead of using scripts or that imperative way of doing things. And you can specify resource dependencies to ensure that resources are deployed in the correct order. So just want to remind you all, if you want to go ahead and do this particular module and start the learning path, you can go to this URL right here underneath the screen. Deploy and manage resources in Azure by using Bicep. Go there, cda.ms 2by, and you can gain access to doing this. So control panel and data plane. You can execute two types of operations in Azure: control plane ops and data plane ops. Use the control plane to manage your resources. Use the data plane to access features that are exposed by a resource. So control plane, create a VM. Data plane, what the actual, SSH methodology is for a VM. Like, is port 22 open? Is for my Windows, is RDP open? So that's essentially what you would do, your data plane operation to connect to your virtual machine. So here is kind of a look at the control plane from a big, broad standpoint. And so all these things essentially utilize SDKs, software development kits, that are for a specific language. And in this case, Azure PowerShell, it's PowerShell. The Azure Portal kind of skips that code method. And so there are also REST clients. So all constrained operations are sent to the resource manager URL. For example, the create operation for virtual machines is just a control plane operation, and here's URL requests. So if you're using Postman or something, or curl, you could utilize this. And you can basically do a put command via HTTP if you want to create resources. The data plane, requests are sent to a specific endpoint, your Azure subscription, to detect the language, operation, and cognitive services, a data plane operation, because the request URL is. And so see here, if we're accessing the data plane, it's giving specifics to that language API. So let's move forward a little, because I want to keep this pretty quick. We got about less than 15 minutes to finish up. What are ARM templates? ARM templates are files that define the infrastructure and configuration of your deployment. When you write an ARM template, you take a declarative approach to your resource provisioning. Why use them? We talked about it before: repeatable results. They're idempotent, which means you can repeatedly deploy the same things over and over, and it should always get you that same result. Okay. Orchestration: when a template deployment is submitted to a resource manager, the resources in the template are deployed in parallel. So it's not waiting one at a time. It's going through and creating everything that you need. Preview: the what if tool available in PowerShell and Azure CLI allows you to preview the changes to your environment before a template deployment. So if you want to dry run and make sure what's going on, it'll give you a faked version. Testing and validation, you can use the ARM template toolkit to test your ARM templates before deployment. So just like we would do in writing software, we can write tests and have that happen to make sure that everything we expect to work does work when we execute our template. Modularity, you can break up your templates into smaller components and link them together at your deployment, like I mentioned to who was asking before? Kevin. So as I mentioned to Kevin, you don't have to just have one giant template. You can link individual modules into separate templates, link them together, and then deploy it, and it'll run all those linked templates together. Extensibility with deployment scripts, you can run Bash or PowerShell within your ARM templates. So if you need to run a little script within your ARM template to do something, like maybe you want it to attach a bunch of disks and then format those disks so they're with a specific type of file system, you can do that. Through extensibility, you can use a single ARM template to deploy a complete solution. And that's important because then you don't have to do a bunch of different processes to have one environment. And so the two types of ARM templates that are available today, Json and Bicep. So JSON is an open standard. Bicep is a DSL, a new domain-specific language that is recently developed for ARM templates. So what is Bicep? Let's keep moving along. Bicep is a resource manager template language that is used to declaratively deploy Azure resources. So like I said, it's a DSL, a domain-specific language. It's designed to a specific scenario or domain. Chef has Ruby as its DSL. I think Pulumi uses Python. In this case, ARM is using Bicep as its DSL. So Bicep is intended to be easy to understand and straightforward to learn, regardless of your experience with programming. All resource types, APIs, properties are valid in these templates. So you'll see if you previously looked into JSON, you'll notice the Bicep simplifies the template design. And that was a great way to kind of look at these two resources next to each other. As you can see that there's a lot going on here in this ARM template. And this Bicep template kind of reads a little bit more simply. We can add some comments here. So like I said before, so we can have this kind of like as a narrative. We want to create a virtual machine. We want to create a security group. We want to create a network security group. We want to create a virtual network. So the benefits of Bicep, we'll go through these quickly. Simpler syntax. We can provide a simpler syntax rather than having to write out all this JSON to actually do our deployment. Modules, you can break down complex template deployments into those smaller module files and then reference them in, say, the broader template. Thereby, you won't have to concern yourself with having one giant template. You can link them together, and you can take one of those linked modules and add them to a different environment so you can reuse code. Automatic dependency management. In most situations, Bicep automatically detects dependencies between your resources. This process removes some of the work involved with template authoring. The validation, IntelliSense, we showed you already that here. We can go ahead and utilize IntelliSense to give us snippets to do. We can use VS Code and what's in there to do some validation to make sure that our linting is properly. And so let's take a look at the example of a Bicep template that defines an Azure storage account. The name of the storage account is automatically generated by the template. So you can see we've got this parameter right here that's saying take this name prefix parameter, and in this case, the prefix is storage, and then create a unique string, and then that's going to be the name. It says what our variable storage account SKU is, standard, read access, global. Off top of my head, I forgot. And then eventually what it does is it creates our storage account and the properties, and then it'll output the information. So let's copy this. Go into a Cloud Shell, and let's add null to main Bicep because I've already created this file, and then we'll just do vi Bicep. I use vi. I know I'm old. You can use code. You can do this in VS Code, whichever is. So I'm just copying, pasting what's here in the module. And what we're going to go over next is how to do the deployment of this particular module. So I already created a resource group for it, and I don't need to, but you'll see. But we're going to use the resource group and deploy it using the AZ deployment group subcommand. So we utilize AZCLI to basically kick off this Bicep deployment. So Bicep is built to make it easy and deploy Azure resources. When you deploy resources, you submit the template to the resource manager. So this is me. This is my template that I wrote over here. Then Bicep converts it into JSON that then sends it to Azure, and then Azure does this creation of everything. So what Bicep is doing some transpilation to convert the source code written in one language into another. So it's basically transforming your Bicep template into a JSON template. So if we want to actually do the deployment, the latest versions of the CLI module have been built in with Bicep. You can always type Bicep, AZ Bicep upgrade to get the latest version of the Bicep binary in your Cloud Shell. See, there you go, install Bicep. And if you just do Bicep main Bicep, it will use Bicep help. I forgot how to do this right here. Oh, there it is, Bicep build. We can see here what it actually looks like and how it will go ahead and convert it. And then what I think it'll do is cat main.json. So it outputs that main.json file. And so what that's basically what it's doing is it's taking the contents of main.bicep and then building them into what is a JSON file that'll be read by the Azure Resource Manager and deployed. So let's deploy this. All right. So I'm just going to copy. I'm going to put up a quick code editor so we can see. Turn on word wrap. Word wrap was in here. All right. Well, let's just go over what's going to happen. So we're going to run AZ deployment, which deployment is the subcommand for the Azure CLI. The group name that we're going to create, and then we're eventually going to use a template file. And in this particular template file, we're going to use this main.bicep. It's in our local directory we're running it from. And then we need to specify the resource group. Okay, so storage resource group, we've already created that. And so now all I have to do is go in here, copy and paste this command in. And so now it's going to start the deployment process. So AZ deployment group will take the template file, main.bicep, and it will build Bicep file, build the Bicep file into a JSON file. And then that JSON file is eventually, you can see here, it's running and it's sent to Azure Resource Manager. One of the cool things, and let me open up our file here. So you can see all this output information that we got. Let's take a look at it. So everything when we build via ARM in the Cloud CLI, we get some sort of output in JSON format of what was built, where it was built, how it was built, and what are the resources available. So here are all the resources available, resource group, storage group, tags. We didn't add any specific tags to this. And then what we did, the type was a deployment. So let's close this. Actually, code Bicep. Save that. And so the output will give the storage account ID string. Let's find that. There it is. So in the output, it makes sure that we have this direct URI to the subscription, the provider, the storage account. And so let's go into the actual portal and let's take a look at it. So we'll go to resource groups, storage resource group like we created. And there is our storage that we generated. All right. And if you take a look and you go over to deployments in the resource group, you'll see that our main deployment was done right here. If we go one step into it, we'll go to our storage account. We can actually go to export, I believe. Is that in here? Yep, export template. And we can export the template in straight up JSON and see what was created. If we want to save the JSON version of it, we can. All right. So let's wrap up everything. Okay. When to use Bicep. You found that many tool sets are available for infrastructure as code. Is Bicep the right tool for you? I think that it's pretty easy to learn. Easy is relative. It's definitely a little bit more readable than, say, JSON. So Bicep has advantages. It won't work as a language for other cloud providers, though. So let's talk about when it's the right tool. When you're working with Azure native specific resources and you want to just build these types of things for Azure. The Azure integration, ARM templates, both JSON and Bicep are fully integrated with the Azure platform. Azure Support. Here's where it really works for you. There's a full support for this from Azure. So if you need help with problems with your Bicep templates, you can get it. No state management. That's a big difference between this and Terraform. Terraform keeps state files. Bicep doesn't. So you won't need to keep the current state of your resources in a file that you keep in your template. Easy transition from JSON. If you've already started using ARM JSON templates, it isn't that difficult to process. And you can use the Bicep decompile command. Take a look. When is it not the right tool? When you have an existing tool set. So if you're already using something like Ansible, whatever, you might not want to use it. You may already be invested. Same thing with multi-cloud. If you have multiple cloud providers that you're working with, you may not want to use it because it's only for Azure. You might want to use some sort of open source tool. So let's do a knowledge check. Suppose you're deciding on a method to deploy your Azure infrastructure. Which of the following characteristics is the benefit of using infrastructure as code? And we can say that infrastructure as code requires you to deploy on a single environment. Consistency of your deployments. I think that consistency of the deployments is the right answer. Suppose you've decided to use infrastructure as code for resource provisioning. You've decided between using an imperative or a declarative approach. Which statement best describes declarative code? With declarative, you execute a sequence of commands in a specific order. With declarative, you can use code, object classes, and and then 3, declarative, you can only specify the end config. So I believe it's 2. And then suppose you're deciding on the type of declarative template you want to use. Which of the following is a declarative template for Azure? It's Bicep. And then suppose you're deciding on a type of declarative template for your resource provisioning. Which of the following characteristics is a benefit of ARM templates? And modularity. Absolutely. So let's do a check. Oh, I got the first one wrong. Let's try it again. I think it would. Whoop, my bad. So let's try this. Infrastructure. Okay. Bicep template. Let's check my answers. I still got it wrong. It's declarative code. End-to-end tasks. Let's check my answer. Yep, there we go. So that's it. Congratulations. I finished the whole module that we did together. You can start working on this module yourself. As you can see, it only took me about 45 minutes to go through this. If you read as fast as I do, you can do it as fast as I did. And if you need help There are plenty of great people to work with. The subject of this video, at Bicep Lang, is in there. That's the Bicep Twitter account. You can send messages that way. Anyway, I got to go to a meeting. It was great talking with you all today, and I'll see you next time. We'll go through maybe another module together. All right? Bye-bye.